Chapter 4, Loops, Part 3. So when do we use a for loop? You can use a while loop for anything that you can use a for loop to do. However, for loops are very handy when you need a count-controlled loop because they include the initialization, the condition, and the update all in one line. So it's a little bit easier for a programmer to follow what's going on than if one had used a while loop. So if you're planning a for loop, let's say, for example, you want to calculate an increasing balance based on a certain interest rate. You decide when you want your loop to start, such as year equals 1, and for how long you want to loop, say year less than or equal to some number of years. And then inside the loop, you've got to update the balance, print the year-end balance, and increment year. But notice, when you are, so we show that in the for loop in the flowchart. However, notice inside the for loop that increment of years, it happens in the for loop header. But it's also important to note that the order follows the same order as shown in this flowchart. Initialize, test, update. That's the order. You don't update before you execute the loop one time. You initialize, you test, you execute the loop, then you update and test again. So here's an example of some code for an investment table, and I encourage you to hit the pause button, type this code up, and see if you can get it to run. Running into syntax errors or red squigglies will certainly help you as you are trying to figure out what the code does. Also, note that in NetBeans, which is the development environment that we are using, you do need that package statement up at the top that is not shown in this image. Some good examples of for loops. It's say if we had for I equals 0. Notice we didn't say int I there. This assumes that int I has been defined before we hit the for loop. For I equals 0, I less than or equal to 5, I plus plus. That loop will execute 6 times, starting at 0 and ending when I gets to 6. It will not execute when I is 6. Here's another example. If we initialize I to 5 and we continue looping while I is greater than or equal to 0, and then we decrement I minus minus, because we're counting down. Counting up or counting down, it doesn't matter. It's just what's more important is what are you doing in the loop? What makes more sense logically? You can also increment or decrement the loop by more than one. For example, for I equals 0, I less than 9, I equals I plus 2. So we're modifying I by 2 each time through the loop. Be careful of this, however, because if you have for I equals 0, I not equal to 9, I equals I plus 2, that's an infinite loop because I will never equal 9 given the start value and the increment value. Or you can also update by other means. For example, for I equal 1, I less than or equal to 20, I equals I times 2. So that also is correct and perfectly legal. In the last example, for I equals 0, I less than str.length, I plus plus, will take you through each character in a string. str.length is a common stop value. Note that we start at 0 because the index of the first character in a string is always 0. It's important to think about variable scope. The scope is also known as the lifetime of a variable. And let's say we're using x as our loop control variable in this example. For int x equals 1, x less than 10, x equals x plus 1. And we execute the loop until x is 10. And then after the loop, if we try to reference x, as in if x is greater than 100, that's not going to work. That's going to be a syntax error because x is defined inside the loop. Therefore, when it hits the close brace, it goes out of scope. Its lifetime is over, and we can't access it anymore. A solution to this is to declare x outside the loop before we get to the loop, such as int x, and then inside the loop, for I equals 1, x equals 1, x less than 10, x equals x plus 1. So we've declared it before we get to the loop, so now we can continue updating it, but it will be available to us after the loop is over. Use for loops only for their intended purpose, and increment or decrement by a constant value, such as 1. Do not update the counter inside the body of the loop. It's legal, you can do it, but it's bad style because it makes it more difficult to follow, and it could possibly have your loop not loop the number of times that the user expects or the programmer expects. So always update that loop control variable in the third section of the loop header. Most counters will start or end at 0 or 1, and many programmers use an integer named I for index or counter as the loop control variable in for loops. Choose bounds that match your task. For example, if we're looping through a string, we'll want to start at an index of 0 and keep going until I is equal to str.length. It's also helpful if we use symmetric conditions, the same conditional operator for both bounds, as in 1 is less than or equal to I is less than or equal to 10. That's called symmetric. And that's sometimes more helpful than using asymmetric, such as 1 is less than or equal to I less than 10. Both work. And asymmetric actually works well with strings because we start at 0 and we end when I equals string.length. It's common to have off by 1 errors, so it's important to count the iterations. For example, in this slide, the author suggests that you count the posts, and you'll see that there are 4. And how many pairs of rails are there? There are also 4. We don't, not counting, of course, that post that's off in the trees or those rails that are off to the right. It's just important to make sure that you are iterating the exact number of times that you think you are.